Hello viewers, welcome back. So today we're going to cover a topic called redox reactions. So redox basically just means oxidation, reduction, reactions. If you don't know what oxidation and reduction means, it's okay, we'll cover that in a while. Alright, so oxidation can be described as gain of oxygen, a loss of hydrogen, or a loss of electrons. Alright. However, for reduction, we can describe it as a loss of oxygen or a gain of hydrogen or the gain of electrons. Alright, so now we've got that straight. Let's go into further detail on how to find out what's a redox reaction. So I'm going to talk a little bit about oxidation state. Alright, so basically oxidation state is a number assigned to an element of a substance to represent the number of electrons it has lost or gained by the atom of the element in the compound. Alright, so basically I'm just gonna cover a little bit, so let's bring in a few atoms here, molecules. So we got sodium, potassium, let's do zinc. For molecules, I'm gonna do oxygen molecule and hydrogen. So these are elements. So basically the oxidation state for these elements are just 0. Okay, these are the oxidation states. Now I'm gonna bring in some ions. So sodium ion, barium ion, let's do oxide and chloride. Alright, so we're going to talk about the oxidation state of these ions. So the oxidation state basically, like I just said, represents the number of electrons it has lost or gained. So over here it's a plus, so we can actually just mean that it lost an electron. So the oxidation state is +1. For barium it's +2. For oxide it's -2. For chloride it's -1. Kind of getting the gist here, right? Okay, so what about compounds? Yeah, compounds. Let's do aluminum oxide. Yeah, let's do aluminum oxide. So as a compound as a whole, its oxidation state will equal to 0. Well, let's say I want to find the oxidation states of aluminum in aluminum oxide. Now, how do I do that? Okay, so we have to look at them separately. So I know that oxygen in aluminum oxide, it's as an oxide form. So its oxidation state will equal to -2. Okay. But for aluminum, that's what I'm trying to find. So I know that when the oxidation state of aluminum in this aluminum oxide, when added with the oxidation state of the oxide in this aluminum oxide, must form 0. So I can write it as Al2 plus 3, so 3 times -2, because that's the oxidation state of the oxide. That will equal to 0. So Al2 minus 6 will equal to 0. So Al2 will equal to +6. So the oxidation states of aluminum will equal to +3. There you go, I found the oxidation states of aluminum in aluminum oxide. Alright, so let's go talk about, let's do sulfate ion now. So for the sulfate ion, its oxidation state would be -2, because here, that's its oxidation state. So let's say I want to find the oxidation state of sulfur in sulfate. Okay, so yeah, same thing as just now. So we just gonna write here S plus 4 times -2. plus the OS above will equal to -2 in sulfate. That will give me -2. So S minus 8 will give me -2. So I'll bring the 8 over, so S will equal to +6. So the OS of sulfur in sulfate is +6. Alright, we've got that? Okay. So let's take a look here. Why is oxidation a gain of oxygen? And why is reduction a loss of oxygen? Alright, so I'm gonna talk a little bit about a reaction now. So magnesium plus oxygen gas, it will give us magnesium oxide. Gotta balance it, okay. So basically, we do know from this reaction that magnesium gains oxygen to form magnesium oxide. Alright? So since we know that magnesium gains oxygen, we can say that magnesium has been oxidized. And oxidation has taken place. But why is a gain of oxygen result in oxidation? Okay, now I want to take a look over here. Charge of magnesium in magnesium oxide is 2+. And for oxygen, it's 2-. So from here, we can technically see that oxygen has gained electrons. And magnesium lost electrons. Okay, so since we know that oxidation is also a loss of electrons, and magnesium lost electrons because its electrons got gained by oxygen, we can also say that magnesium got oxidized because it lost electrons. And that is why we say a gain of oxygen is oxidation, because it will result in the loss of electrons of its partner. Alright? Okay, let's take a look at... Okay, why not we look at this from the backboard? Oh wait, sorry, my bad. Okay, never mind. Okay, let's do hydrogen gas plus oxygen gas gives me water. Okay, I've got this. I'm gonna even it out, balance it. Okay. So now I'm gonna talk about why a gain of hydrogen is reduction. So over here, we know that oxygen gained hydrogen in order to form H2O. Okay? Now, why is a gain of hydrogen reduction? Since oxygen, okay, hold on. So oxygen is reduced due to gaining hydrogen. Okay? So we're gonna do the same thing again. Look at the charges here. Hydrogen has a charge of plus, oxygen has a charge of 2-. Okay? So from here we can see that oxygen gained electrons and hydrogen lost electrons. So we're taking a look from the point of view of oxygen. Since oxygen gained electrons, and we know that a gain of electrons is reduction. So basically, because hydrogen is the one who lost electrons, that means oxygen must have gotten the electrons from hydrogen. So therefore, gain of electrons is also known as reduction. That is why a gain of hydrogen will lead to reduction. Okay? Alright, yeah, let's do a few practice. Okay, let's do this one. Zinc oxide plus carbon will give me zinc and carbon monoxide. Alright, so firstly, I'm just going to identify what is oxidized and reduced. But before we do that, I'm going to talk a little bit about oxidizing agent and and reducing agent. So basically, an oxidizing agent is a substance that causes oxidation, but it itself will get reduced. And for reducing agent, you can guess it. It's basically the opposite. It's a substance that causes reduction, but it itself is oxidized. Alright, so we're gonna go back here. We're gonna find out what has been oxidized and what has been reduced. So we're gonna look at the OS of each of them here. So let's do zinc first. So zinc and zinc oxide, what's its OS? So we know that zinc oxide's OS is 0. So Zec and minus 2 equals 0. So the OS of zinc and zinc oxide is positive 2. Alright, now let's take a look at zinc here. So zinc by itself, its OS will equal to 0. So as you can see, its oxidation state, there has been a decrease in the oxidation state. So since the oxidation state has been decreased, that means that electrons was gained by the zinc. So therefore, zinc oxide has been reduced. Okay, so now let's take a look at carbon here. So carbon by itself, its oxidation state will be 0. And carbon and carbon monoxide will be, carbon monoxide as a whole will be 0. So carbon will, the OS of carbon will equal to positive 2. And as you can see here, there has been an increase in the oxidation state. And that will mean that electrons were lost. So therefore, it has been oxidized. Oxidation has taken place. Alright? So from this, we can say that because the oxidation state of zinc oxide, of zinc, because it decreased from positive 2 in zinc oxide to 0 in zinc. So therefore, we can say that zinc oxide has been reduced. And as for carbon, we can say that the oxidation state of carbon increased from 0 in C to positive 2 in carbon monoxide. So therefore, we can say that carbon has been oxidized. And there you have it. So now, we're going to identify which one is the oxidizing agent and which one is the reducing agent. So, yeah, let's come here. Which one is the oxidizing agent? Now, we know that the oxidizing agent is something that causes oxidation and it itself will get reduced. So what reactant here causes the oxidation to occur and it itself gets reduced? Now we know that zinc oxide gets reduced and it causes carbon to get oxidized. So therefore, zinc carbon is your oxidizing agent. We're just going to call it OA, yeah? And we know that the reducing agent is something that causes reduction and it itself gets oxidized. So we see that carbon over here gets oxidized itself, but it causes zinc oxide to get reduced. So therefore, this is our reducing agent. Alright? So yeah, we got that. So there are a few substances that can be both the reducing and oxidizing agent. And one example is hydrogen peroxide, H2O2. It can be a reducing agent, or it can be an oxidizing agent. So let's take a look at the decomposition of hydrogen peroxide. Yeah, that's what we'll get. And yeah, that's the balanced one, is it? Yeah, it is. Okay, so back to here. So now we're going to talk about the decomposition of hydrogen peroxide. So we're going to talk about the oxidation state of oxygen in hydrogen peroxide. So the oxidation state of hydrogen peroxide is 0, but we're trying to find the oxidation state of oxygen. So O2 plus 2 equals to 0. So therefore, the oxidation state of oxygen will be -1. All right. Now let's look at the oxidation state of oxygen in H2O. Oxidation state of H2O will be 0. So oxidation state is 2 equals to 0. So oxidation state of oxygen in H2O will equal to -2. Okay. And lastly, let's take a look at oxygen here. So the OS of O will equal to 0 because it's just a molecule of an element. So as you can see here, from -1 to -2, hold on, let me use another color. From -1 to -2, there has been a decrease in the oxidation state. And a decrease in the oxidation state will mean that electrons are gained, and thus we can say that reduction. It has been reduced. But from hydrogen peroxide to oxygen, the oxidation state increased. So therefore, that will mean that electrons were lost, and therefore oxidation has taken place. So as you can see here, hydrogen peroxide can act as a reducing agent and a oxidizing agent, as it causes oxidation to occur, but at the same time it causes reduction to occur as well.